Okay, let's take a look at problem number 9. So this problem here is asking us to determine the node voltages. So it's these values V1 and V2 here. And then also wants us to find this current I of S. All right. Um, and you'll notice that they give us a few things here, such as a voltage source and then a current source. They also provide a ground for us, so that's nice. So that'll equal 0. But you'll notice um, on this branch, there's only a voltage source. So that's going to be an issue when it comes to doing the nodal analysis because, uh, whenever we write out V start minus V end over R, well, along that branch here, there is no R. So we can't really do that. So we had to do this thing called superposition, where what we're going to do is take, um, real quick before I do that, we'll see here that there's nothing in between those 2 points. So this point and that point are the same point. They have the same voltage. So I'm just going to scoot this over like that. That's V2 still. Okay, so now that's more of a complete item. But anyway, so what we had to do is call it superposition. So superposition. And that's going to occur whenever you have a branch with just a voltage source on it with no resistance. So what you're going to do is you're going to take that entire branch and draw a nice big potato around it. And you're going to take every wire and act like there's a current leaving from it. So there's one, there's one, there's one, here's one. Now notice we have this 1 amp here. We know 1 amp is going to be coming this way. So this is the only one we're going to assume that's entering. The rest are leaving. So if we come over here, back to our superposition, we're basically acting like that's one big node inside of that. So what we'll do is we'll say that, let's go ahead and just give a bunch of these names. So I'll call this one I1, call this one I2, I3, and I4. And then this is just 1 amp. All right, so I'll come in here and I'll say, all right, plus I1 plus I2 plus I3 plus I4, and then minus 1 amp is equal to 0 because minus is entering. Okay, and then now I'll continue on with the I is equal to V over R. So what we'll do is for I1, we'll say V1 minus VG over R1. Then we will come to I2, we'll say V1 minus V2 over R1. Then we'll say I3 is V2 minus V1 over R1. I4 is going to be V2 minus VG over R2. Then we're going to subtract 1 off, 1 amp off, and that'll be equal to 0. Okay. And then what we'll do now is we'll just come in and we will plug in what we know. So we know V of G is 0. We know V of G is 0. We know R1 is 3. R2 is 12. So we will get V of 1 over 3 plus V of 1 minus V of 2 over 3 plus V of 2 minus V of 1 over 3 plus V of 2 over 12 minus 1 amp, and that'll be equal to 0. Now what we'll do is we'll come in here and multiply by a common factor. So multiply by 12. We get 4V1 plus 4V1 minus 4V2 plus 4V2 minus 4V1 plus V2 minus 12 amps is equal to 0. And then we'll just come through and we'll combine like terms. Let's see, that goes away. We'll see that goes away. And then we will be left with 4V1 plus V2 is equal to 12 amps. And that'll be our first equation. So where do we get a second equation from? Well, that's a great question. So the interesting thing about the supernode is that here, if we were to draw it out, like that, where this is V of 2 and this is V of 1, and then this was 10 volts. What this means is that we're going to start with the voltage at V of 2. We're going to travel through it, and we're going to pick up 10 volts, and we're going to end up at V1. So our equation basically says that V of 1 is equal to V of 2 plus 10 volts. You can also say V of 1 minus V of 2 is equal to 10 volts. All right, and this is our second equation. All right, then to solve it, we'll just need to solve the system of equations. So I'm going to come in and say, I'm going to plug in 4, I'm going to plug in this equation. So 4V of 2 plus 10 plus V of 2 is equal to 12. So 4V of 2 plus 40 plus V of 2 is equal to 12. So 5V of 2 is going to be equal to this will be negative 28. So V of 2 will be equal to negative 5.6 volts. Okay, then we'll just come over here to V of 1, and we'll say plus 10 volts minus, or plus minus 5.6 volts. V of 1 is going to be equal to 4.4 volts. All right, but then now we need to figure out what I of S is. So to do that, all we need to do is write a KCL. So if I do KCL at V of 1, I'll have I of 1 going that way, I have I of 2 going that way, I of S going that way. So I'll have I of S plus I of 1 plus I of 2 is equal to 0. And then I can come in here and start replacing things that I know. So I can say I of S plus, for I of 1, it'll be V of 1 minus V of 2 over R1 plus V of 1 minus V of G over R1 will be equal to 0. So I can say I of S will be equal to, let's just do this. I of S plus V of 1, which is 4.4, minus V of 2 is negative 5.6, over R1 was 3, plus V of 1, which is 4.4, minus 0 over 3 equals to 0. Therefore, if we rearrange and solve for I of S, so we get I of S to be equal to negative 4.8 amps. Okay. Oh, so what does that mean? So the way they described I of S going that way, and what it actually is doing is going that away with 4.8 amps. Okay, so our assumption was wrong whenever they gave it to us in the problem statement.